Good morning everybody. Today we are discussing our relations and functions class 12 NCERT exercise 1.1 question first second part. First already we have discussed. Check whether relation R in the set n of natural numbers defined as R is equal to x comma y such that y is equal to x plus 5 and x is less than 4 is reflexive, symmetric and transitive. So here first of all let us see the question in a proper manner. It is relation R in the set n as n of natural numbers, means natural numbers are only allowed to fulfill the condition of the relation. So here the solution starts. First of all we will have to write the relation R. If I am putting in place of x, because natural number starts with 1, so we are starting with 1. If I am putting 1 in place of x, so it will be y is equal to 1 plus 5. So y is equal to 6. So on putting 1 we are getting 6. On putting 2 we are getting 7. 2 plus 5. 1 plus 5, because it is starting from 1. Natural number always starts from 1 and relation is defined in the set n of natural number. That's why I am starting it from 1. So 1 plus 5 is 6. Now after 1 there is 2. 2 plus 5 is 7 and after 2 3. So 3 plus 5 is 8. Now 4 is not allowed because x is always less than 4 according to the given condition in the relation. So we are bounded by this condition. First coordinate will be 1 comma 6. It is domain and it is range. Now second value of y is 7 on putting x is equal to 2. Here x is equal to 1 we are putting. Here x is equal to 2 we are putting. And here x is equal to 3 we are putting. So on putting x is equal to 1, y is equal to 6. On putting x is equal to 2, y is equal to 7. And on putting x is equal to 3, we are getting 8 here. So 3 comma 8. This is only the relation. Why is it so? Because 4 is not allowed. X must be less than 4. So this particular relation is there only. Now there is no need to put this part with us. Now after that, let us check the reflexivity. We have to check the reflexivity, symmetry and transitivity. So reflexivity I am checking. In reflexivity we will have to check same elements in both the places. 1 1 2 2 3 3 4 4 is not there. 1 1 2 2 dash 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 is not the element of relation. So because AA is not the element of R, so what we can say, AA is not element of R means we can say that therefore R is not reflexive. The relation is not reflexive. This relation is not reflexive. From here it is clear. Now let us see symmetry. Symmetry. 1 6 is element of R. See, our first coordinate 1 6, but 6 1 is not element of R. So 1 6 is element of R, but 6 1 is not element of R. Therefore we can say that R is not symmetric. R is not symmetric. What is the reason? Because AB is element of R implies that BA is not element of R. What is the condition for symmetry? That you know very well. That if 1 6 is element of R, then 6 1 should be element of R. Then only it will be symmetric. But here 6 1 is not element of R. 6 1 is not given in the relation. That's why this relation is not symmetric. In transitivity, one 6 is element of R and 6 11 is not element of R. So one condition only followed by here in transitivity. One given condition of transitivity is not followed here. So how can we discuss 111? So because AB is element of R and BC is not element of R. So we do not need to discuss AC. We do not need to discuss AC. Therefore, because the primary condition of the transitivity is not followed by our relation, so we can say that this relation, the relation is transitive here. Relation is transitive here. See, it is very minor point which we have to check properly. Let us see what. If AB is element of R and BC is element of R and AC is not element of R, in that case we can say that relation is not transitive. But if the primary condition of the transitivity is not followed, so how can we discuss the secondary condition of the transitivity? That's why we are writing here the relation is transitive. This is only the proper mode to see the transitivity of the relation. So here only we are able to conclude it. Now, what is conclusion? Conclusion is R is not or we can say neither reflexive nor symmetric, but it is transitive. But it is transitive. The relation R is neither reflexive nor symmetric, but it is transitive because the primary condition of the transitivity is not